welcome to another episode of the Everything Electric podcast, where today we are talking about tyres. And more specifically, how thinking a little bit more sensibly about your tyres could mean that you could go further, more quietly and more safely in your electric vehicle. Now, this is such an enjoyable conversation. It's actually been a few hours since I finished the conversation with Neil Barrett, who is the EV lead at Hankook. And I had a right old lovely time. And I really hope that you do too and come away with a few more tyre facts up your sleeves. So all of that to come. But first, a very quick advert break. Our 3 free YouTube channels on EVs and clean energy tech are funded by our fun-packed test drive-tastic events in the North, West and Greater London, and our events down under. Next up, Everything Electric Sydney 2026. Plus, check out everythingelectric.store for merch and much more. Neil, thank you so much for giving up your afternoon to come and speak with me today.
Pleasure.
It's an absolute total delight to talk about all things tyre related today.
Excellent.
And I suppose we should reassure the audience who might be thinking, is this going to be that interesting? That yes, it is going to be interesting because I know you have many a tyre fact.
Indeed. And I've spent a lifetime accruing them. So hopefully one or two will be interesting. It can be dry, it can be technical. We'll keep it as light as we can. But we're going to have to dive in deep on a few bits, I'm imagine. So,
we are. There's going to be some stuff for everyone, some stuff for the nerds,
yeah,
some stuff for people who, are yet to be convinced that this is the podcast for them. We'll see where we end up.
Okay, great.
But before we get into it, can you tell us a little bit about yourself and specifically what you do at Hankook?
Okay, so, I'm Neil. I'm EV lead and key account manager at Hankook. So I've been with them. I'm in my 12th year now. So that was quick. And really, my role within this, apart from my key account manager role, is to, I guess, be the sort of EV tyre guru. We provide training. I monitor trends, try and help out and inform people what's going on in the market, what sizes are growing. I mean, there's a new size every week we've got to keep our eye on. Make sure we make it, make sure we got them, make sure we've developed it, more importantly. And a sort of general spokesman on it, really. So I guess I was in the right room at the right time, I guess, for all the EV. And I just am fascinated by EVs.
And I think that is something that we're going to get into in this podcast, that actually when it comes to EVs, the opportunities for tyres to do something slightly different and to aid performance gains is actually really huge.
Absolutely.
But before we get into that, I wonder when you chat to your friends and family and say what you do, do you have a favourite tyre fact that you whip out from your rear pocket?
Do I have a favourite tyre fact? I've got a new tyre fact, actually. Don't ask me to remember what I said to my friends and family about tyres. I mean, God, I've been doing it long enough. 23 years, more to the point. But here's an interesting one. I think it's interesting. But did you know, thanks to EVs, cars can now accelerate faster than they can brake?
Wow.
Never happened.
That's never happened before.
No. Not that I can find. I'm sure someone can delve deep into the archives of some information somewhere. But generally, as a rule, it was always assumed that cars could not accelerate faster than they can brake because it was never needed.
That is absolutely fascinating. And this is the power of, people being able to comment below. If anyone wants to contend this fact, please do. Please quote your sources in those comments as well. But how interesting. I'm trying to think about when I run. Do I accelerate quicker than I slow down? I'm not sure the answer to that, I have to say.
I think it's to do with the physics and the technical prowess of the tyres. And, when they've done calculations about how fast cars can accelerate, generally speaking, it's never even been near because ICEs just cannot put down their power quickly. Well, they can't really. If you can imagine, they're not really producing their power until they're revving to 2,000 revs or, in a fast start, maybe 3,000 revs and there's wheel spin. But EVs are so efficient. They do take a toll. It's indicative of the toll the tyres take on an EV. I think That's not really why I said it, but now I say it. It is. I mean, it's a perfect example of the stresses and strains they have to deal with, and why we have to think about them differently. I'd imagine.
Well, I think you've allowed us to segue perfectly into our next bit of this conversation, which
Very
is
good.
when it comes to electric vehicles, why is it that we need to think about the tyres slightly differently?
I think if we look at it in the round, if you want to pick out 2 points, it's the rapid increase in power versus the need for efficiency.
And presumably, those are two conflicting requirements.
Generally, they were accepted that they were. So tyres have developed hugely in the last, well, we can say 100 years. It's the same technology, really,
Mm.
in shape. In it's rubber, it's mounted to a steel or alloy wheel, but yes, it's always been assumed that to have the grip and traction you required for a high power, you have to trade off efficiency, and that's just simply not acceptable with EVs. Just
Mm.
can't happen. I mean, in some rare cases, very high performance EVs, they allow it, and I think
Mm.
customers accept that that's a trade off. But we're not talking about high performance cars per se. We're not talking about cars that people buy for high performance. We're talking about family cars that are designed to carry 5 people with over 500 horsepower.
Yeah.
I mean, that's where we are. That's the reality of it. So, from a technical standpoint, it's a challenge. It's a
Mm.
real challenge. I mean, we've never been in this situation before. So, when we're asked the question, why do they need a different approach to the sort of design of tyres, then really those two bits do summarise it quite nicely.
Mm. So the implication being that we still need that high efficiency, but the performance of EVs is such that they're putting greater stress on those tyres,
Yeah.
which presumably means a faster wear rate if you were to just use standard tyres on an electric vehicle.
Yeah, I mean, in essence, there's a number of things that affect wear, power, and weight, and these are all things I'm sure we'll touch on when we talk about characteristics of EV.
Mm.
But obviously, if you've got a vehicle that's got 500 horsepower and weighs 2.5 ton, it will, unchecked, wear tyres quicker than a vehicle that has less power and less weight.
Mm.
That's just a real fact. But obviously, knowing those and knowing that those sort of design parameters need to be baked in at the beginning, it allows us really to go to town with the individual technical elements that we've gone into with the Hankook Ion.
Mm. Okay. So presumably for a company like Hankook, who is like, well, every car needs four wheels at least, or four
Four
tires at
tyres, yeah,
least.
absolutely.
Um, and the direction of travel is towards electric vehicles. That poses an enormous opportunity to innovate something slightly differently. So, what is Hankook's approach? And I suppose sub bullet to that question is, what are the specific characteristics of EVs that require that slightly different approach?
Okay, so the initial approach, or the approach we've taken to market, is we've brought out an EV specific tyre, a sub brand. It's called Ion. It's available in a number of patterns. We can go into the individuals, but in terms of what we're looking at, the main factors that influence tyre performance, wear, rolling resistance, etc. So you're talking about the weight of the vehicle. So when we talk about weight, we're not talking about a static weight. We're talking about a dynamic weight.
Mm.
Weight transfer under braking, under cornering. Okay, it causes massive loads on the tyres. So we've got to develop tyres to be able to accept that. 50% of the noise in the cabin of an EV comes from the tyres.
And that's
50%.
because it's no longer able to hide behind the sound of
It's
engine
exactly what
noise.
it does. And,
Mm.
and, and we filtered it out. I mean, even luxury cars. I mean, luxury cars, they got a lot of soundproof, sound deadening materials and everything else. But even luxury cars, they cancel out frequencies that the tyres would have normally sort of produced. So therefore, it's going to be more noticeable. It's going to be the main sort of noise point
Source.
in the car.
Yeah.
Yeah, exactly. So these again, but in that we have to factor in the requirement for a low rolling resistance.
And for those who might not be familiar with low rolling resistance. Can you just define what that means?
In its easiest form, it is energy wasted as heat. So as a tyre rolls down the road, as the from a molecular level, as the molecules sort of move around within themselves from the tread area, from the sidewalls, from the shoulder area, it will try to produce. It will naturally create heat. There'll
Mhm.
be sort of friction within that. Interestingly, it's something we can talk about with EVs because, or at least a theme that will repeat itself, which is they are the victims of their own success in this.
Mhm.
Because EVs generally use 25% of their energy just to make the tyres roll.
Yeah.
That's across the board. At lower speeds, it's higher. And really, at higher speeds, then aerodynamics comes in and, makes that. But as a general rule, 25% of all the energy in your battery is just there to make the tyres roll. So that's a big window to go at, isn't it?
Mm.
That's that. There's a lot of improvement to be made on that. So, and so all those tie in there. Obviously, with the weight, has an effect on um, wear, and obviously, the thing we alluded to earlier is the sheer power and torque that they actually produce.
So that's an interesting thing because we have, on the one hand, a huge amount of power that EVs are capable of creating from a sort of standing start,
Yeah,
which in a way you're like, well, rolling resistance or low rolling resistance may not be such a problem compared to, say, an internal combustion engine vehicle that's got like a slightly slower start, for example. It's sort of, there's less energy in that exact process.
mm.
But then also, you want to have a low rolling resistance, but you can't necessarily sacrifice grip. And then you want to have an efficiency, but you also have potentially a higher wear rate. So you need to sort of compromise those. So all of these things feel like a very challenging set of conflicting requirements for an engineer.
They are. And I mean, when we came to design the Ion, it wasn't just a case of just trying to put all these things we've learned over the
Mm.
years. We literally had to redesign a process of making it and new materials. So there was 58 patents that we registered during the design of the Ion product
Wow.
range. So I mean that's extraordinary,
So
and
it does allow you to say that you've almost reinvented the wheel, or
it does.
well, tyre.
I will allow you to say that, but yeah, I mean certainly we've really pushed the limits of where the tires can go, and it's interesting because a lot of people just assume that you know back in the day when you needed grip, you needed heat. I think
Hmm.
everyone was sort of comfortable with that as an understanding of it. And what we're saying is one of the big improvements in tyres over the last few years, all of them, is the lack of requirement for heat to produce grip, and that comes down to the compounds we now use, which are unrecognisable for 15 years ago. Absolutely unrecognisable. And I think the way I'd like to think about it now is if do you remember the old light bulbs, the old filament light
Hmm.
bulbs?
Yeah.
I mean, it must be 20 years ago since we've seen them, or they've banned. But
Yeah.
they produce 90% heat and 10% light.
Yeah.
And new LED bulbs produce 90% light and 10% heat. We all accept that. We know we can touch a light bulb now and it doesn't burn ourselves. It won't
Yeah.
burn our hands. So we know that progress has been made in this. It all sort of
Mm.
fits into the whole idea of reducing energy consumption in everything we do. So yeah, it is really a huge focus on this and the way we've gone about it in terms of how we've just I mean, of that 58 patents, 15 were just for the compound. So this is we've done some remarkable sort of improvements in pushing the boundaries
Mm.
and trying to minimize this trade-off that people think is always there. But
Mm.
and the thing is, EVs, because they're so efficient, are huge beneficiaries of this technology.
Because that there's that 25% that you can go after. Actually, if you can innovate,
Yeah.
then you can create huge amounts of gains.
Well, absolutely, and people tend to gravitate towards EVs because of their efficiency and their running
Mm.
costs. I mean, we've got the figures now. We kind of know that ICE are 18 to 25% efficient, and EVs are somewhere approaching 90% efficient. I think it's 87% efficient is the latest figures I
Mm.
got because they regen, because they don't produce the heat that ICEs produce, because they're just generally so well integrated and
Mm.
so logical is the honest answer. So yeah, so if something is very efficient, if something is efficient at its core, then you can trip it up quite easily by forgetting the details. And one of those would be
Mm.
tyres.
So I have so many questions, and I want to
Go.
make sure that I remember all of them.
I'll try and answer all of them.
But I guess beyond the material innovation and really working on those compounds, of which there are many patents are attributed to that of the 58,
Yeah,
are there any other innovations that you're like, oh, this one's a good one?
there's quite a lot. I quite like the way we've gone to town with the noise.
Hmm.
It's that's really quite clever. So we've developed a suite of technologies: I extreme lightness, I super mileage, I sound absorber, I perfect grip. So what these are a suite of technologies that allow us to deal with each individual element of the EV and the challenges it gives. And certainly, if we look at I extreme lightness, which falls under rolling resistance, I mean, there's a lot to be going in with that, and a lot of them cross over. But what I do like when we go to the I sound absorber, there's 5 individual uh, technologies there we've applied. And one of them that I love, which is so simple, really, is the way we've just designed the inside of the tread area, the circumferential grooves. There's some really interesting sort of shapes, a sort of knurling shapes around them, and that makes a hell of a difference. About 3 decibels, really, or 3% of
Wow.
the decibels. It's amazing, and one thing won't do it, but as
Yeah.
a suite of technologies, um, it's remarkable. Even just the technology has gone into the tread to make it quieter as it rolls down the road. Seems perfectly logical, but that links in with every single other one of the technologies that we've gone into on this one. So, I mean, whether we want to go into depth on those, we can, but
Well, so the one that when I was reading the material about the ion range, there's
mm,
one that really struck me, which was around, and I think this is all to do with creating more grip, both wet grip and dry grip. And
mm.
typically, when a tire rolls, the sort of the sipes, they kind of, it's almost like stacking bananas in shape. So
Oh,
if
the
you think
3D sipes.
that's it, yeah, yeah.
Yeah, yeah,
But what Ion is doing is they instead of sort of stacking bananas, which inherently, if you can imagine stacking bananas, they'd have
yeah,
lots of space between them. This is more like stacking Lego bricks, so they sort of lock together in
yeah.
order to create that grip, which I thought was very cool.
Well, not only does it create the grip, but it stops the movement in the tread area itself. So the actual vibration is reduced, which reduces the production of heat, reduces the rolling resistance. So there are at least 2 or 3 different upsides to that technology.
Mm.
So I guess this is a podcast, and it's not potentially a visual medium, but yeah, I mean, it's rather than just a straight line, it goes in little blocks, and so when they're under pressure, for example, under cornering, they solidify together,
Mm.
and it's just a lovely, clever, just one of many things we've done. I think we brought that out originally on truck tires. This
Wow.
3D printing, and it allowed the tread to change as it wears down. And then all of a sudden we think, well, hang on, this has got so many other different applications. I'm sure it was designed within it as well.
What I love about all of this is that when you see all of these things come together and you see, on a table or at a presentation, oh, this creates sort of a 3% gain and this creates a 2% gain or whatever. And then you sort of take a step back and like, this was someone's job to engineer these things.
Yeah.
And I just think that's extraordinary. And it's just so life affirming, I suppose, that there are people out there chasing those gains to push the envelope that little bit further.
I mean, the truth is, it was in terms of engineers, probably hundreds of people's jobs.
Mm, yeah.
And they have to be managed and brought together, working for the same thing. And
Mm,
so many different ideas, so many applications of technology that we've developed, and in this case invented.
mhm.
Now, I don't know if anyone, are you aware? I'm going to ask you now. Do you know how a tyre's made?
Where a tire is made, sorry?
How a tyre's made?
No, I don't
No,
actually.
it's kind of odd. So it goes down a sort of production line, and it's put together. A lot of people involved, a lot of machines, and sort of various rubbers are adhered to each other, and it's sort of glued into the bead, glue at this point, and it comes off, and you look at it and you think, sorry, it doesn't look like a tyre. It looks like a beach ball with a hole in it.
Mm.
And then it goes into the cure. It goes into the mould where it's cured. So, and this, depending on the size of tyre, is cured for 10 to 20 minutes.
Hmm.
And that's where all the magic happens. That's where all the rubbers cure to a point, vulcanization and all that sort of technical, wonderful stuff.
Mm.
The thing is, there was always a problem with that. When you make a tyre that's got different thicknesses, if you looked at a sort of cross section of a tyre, you'd think, well, the tread's quite thick, and then you need a bit more reinforcement, just right at the edge of the tread where it goes into the
Mm.
sidewall, and the sidewall you want thin. Problem is, you'd always have this trade-off really of what's going to be cured right, what's going to be undercured, and really we brought out this basically brand new machine that can cure every part of the tyre perfectly. So that goes back to the design point. So if we can now really stretch, the point of design where we can say we can have that thinner now because we haven't got to worry about
Mm.
the curing compromise anymore. It's just not even an issue.
Ah.
So so it's not just, the production is one thing, but it just sort of feeds back to the design process, which is one
Yeah.
of the reasons why when we look at eye extreme lightness, when we look at the optimization of, the sidewall, because the sidewall does produce a lot of rolling resistance,
Hmm.
but there's just parts of it that just doesn't need to be there. Because we've got to remember with tyres, it's the air that carries the load, not the tyre.
Yeah.
Okay. And one of the reasons EVs have become tricky, let's say, is because of their increasing weight and size.
Mm.
We've got some kind of very much larger sizes, they're much bigger.
Mm.
They're probably 30% bigger in physical size. So it's allowed us really to zoom in and say, right, well, if that tire is now bigger and wider and therefore it produces naturally more traction and the weight of it produces more coefficient of friction, then we can go to town with the low rolling resistance. Now, you can do this on an EV tyre, but on an ICE tyre, you would not get that same benefit, or you would get a trade off or a compromise. So, our insistence on going down the iron was to make sure that everything we put in it would have a benefit to EVs, not
Mm.
a real specific, tangible benefit.
So when you put everything together across those four pillars, those four umbrellas of iSuper mileage, or this is testing me now.
Yeah, you're going
I've
to test
also written
me.
them down on my notes. I'm gonna have a look here.
I
I
can read them
extreme
out for you.
lightness.
Yeah.
Well, you can see if I took them all off. So I extreme lightness,
Yeah.
I super mileage, I
Yeah.
sound absorber, and I
Yeah.
perfect grip.
Yeah.
If you put all of those things together, what does that translate to a driver in an EV in terms of
Okay.
benefits?
In terms of benefits, it'll give you four main benefits. Low rolling resistance will give you more range, less energy use. That could be very important.
Hmm.
It might not be so important, but bear in mind that really, you bought an EV. It should be very important. Quietness should be much quieter. It should be, and you tested me now. You should get much better adhesion with the road because the technology we put into the tyre allows the tread to remain in contact with the tarmac a
Hmm.
lot more. Okay. I mean, one interesting thing I'll just say about when we talk about something we haven't touched on iPerfect grip. When you put in 500 horsepower through tyres, what tends to happen is that they will circumferentially grow, the tyres will expand.
Hmm.
That tends to happen in the centre of the tread, so that'll tend to push up. Well, naturally, that you're lifting the the other sides of the tire, the other sides of the tread off the road, so you're reducing grip, which
Mm.
increases slip, which increases uneven wear, which and all of a sudden you're in this sort of negative spiral. So it's very important, really, that what we've done to that is we've reinforced the right bits with aramid and steel, and we've put variable tensions. So if we can think again of this, if we think again of the cross section of the tire,
Mhm.
if you cut through it, you'd see rubber in the middle. You'd see lots of steel belts going through, and then you'd see what we call aramid. It looks like Kevlar, but we can adjust specifically the tensions of those to make sure that tire doesn't grow under high acceleration. And that is incredibly important because what it means is you've got better grip, better wear, better life, and much more even wear patterns.
Mm.
Truth of the matter is, if you do drive it like they'll go, you're going to get through tyres quicker. I think we know most people don't.
So I suppose I'm just trying to sort of build probably an extremely clunky analogy here, but almost like as a tire rolls, it's almost like imagining that you're trying to do you want to be doing a cartwheel with
Hmm.
the flats of your palms,
Yeah.
but instead someone's doing it on a fingertip and trying to go up onto high onto those fingertips, which would raise you up, but also makes you incredibly unstable. And actually, full palm would be a more efficient cartwheel and a safer cartwheel.
Well, palm is quite accurate, or at least a smaller palm, because that's the sort of contact patch you're looking at.
Mm.
So if you're looking circumferentially at the tyre, you're looking at contact patch of about 2 inches.
Yeah,
Now, as that tyre turns, that contact patch is transferring through a circular tyre. So it's
yeah.
that twisting of the rubber that's causing the rolling resistance that used to cause a lot of heat. And that was where, I mean, heat is the enemy of tyres, always has been in
Mm.
terms of life. So if you get a handle on heat, you get a handle on the life of the tyre.
Mm.
It, I mean, I'm aware of this when we talk about this. All of these individual technical advancements are all interconnected with other
Yeah.
parts. It's very difficult to sort of, just say that does one thing, because if you do everything right, everything will work. That's a bit of an oversimplification, but generally speaking, I'm quite comfortable in saying that. Yeah,
So the thing I have to ask you about, because if I don't, someone in the comments will, is
yeah.
around tire particulates.
Mm.
So how is Hankook thinking about this, and how problematic are tire particulates when it comes to EVs, given that regenerative braking is generally how EVs tend to brake?
Okay, so there is a linear connection between weight and wear, as a rule. The heavier vehicle, the more it will wear. Particulates are an interesting one. That's going to be a function of Euro 7 that's coming out in
Hmm.
2027. And really, if you think about it, and the way EVs have just cleaned everything up, I mean, what other emissions do they produce? They don't use brake pads hardly. They're lasting 150,000 miles
Mm.
on brake pads. So there's no dust particulates from there. So really, it's the last bastion of, pollution from
Mm.
EVs. So yeah, it's going to become a big issue. There's two parts to this and two parts to the answer. Um, One of the things we've done with the Ion is paid a lot of attention to making sure that the life of the tyre is maximised. We claim it's very difficult to claim actual mileage. You can't. Every use is different, but there's a sort of 20% improvement over our competitors in terms of life on these because of what we've done into that, what we put into that, and that will that will have a major part. But the other side is the size of the particulate.
Hmm.
So you're looking for particulates that aren't too small, that are airborne. So that's important. And then the other part of it is what we put in the tyre that become particulates.
Yeah.
And then another part of it is what we put into the tyre that's sustainable or not. So
Hmm.
all these things will come together in one. So um, we are unclear where 2027 Euro 7 rules will fall, but it is important. We're embracing it.
Hmm.
We've had some very good feedback in terms of where our particular levels are at the moment, especially on the Ion. And it's going to be a focus of it because it will probably be the most important thing in the next 3 or 4 years when it comes to EVs.
But then I think what I'm hearing as an EV driver and someone who does care about air pollution is that actually, if we accept that tire particulates are currently a bit of a necessary evil when it comes to tires,
Yeah,
there are ways to reduce that. But an heavier vehicle, generally speaking, would create more wear on a tire.
yeah,
The higher the wear, the more particulates you're releasing into the atmosphere. So actually, as an EV driver, if you can buy a tire that is more suited to the vehicle and can extend its life, it's ultimately per use
perfect,
you're emitting fewer particulates into the atmosphere each time.
perfect, perfect. And we have a lot of examples now where um, people are deciding maybe to cut costs onto. I mean,
Mm.
It's the market. It's the market we're in. It's, we appreciate a tyre is a distressed purchase.
Yeah.
We understand that. But it is important, if we've gone down the EV route, if we own an EV, we have a sort of responsibility, if you like, to continue to minimize its impact.
Mm.
And you can undo a lot of work done by the EV by choosing the wrong tire on that.
Yeah.
Especially when you're buying, an ICE tire that really just isn't built for that kind of power. It really can chew it up quite quickly, and,
Mm.
and and we're back to that again. Because I mean, particulates is important. There's technology that are coming out now to trap particulates, which is positive. But don't forget, when a tire's worn out, it's got to be
Mm.
recycled, disposed of, and really, that's probably as big a problem in the big term. So in the long term, so it is we have to understand that as EV drivers, we have a responsibility to minimise that.
Yeah.
I think that's fair.
And I think it comes back to that old adage of buy cheap, buy twice. And I
Yeah.
suppose it's buy cheap, buy twice, pollute more is what we're also saying there.
Well, I mean, it's interesting because, as I say, no one gets a phone call from the MOT station hearing the news they've got to buy 4 tyres, and no one does a merry dance and says, "Great." Uh, you know what? Motorcycle. I was in the motorcycle industry for a while
Mhm.
with tyres, and they're completely different. When they buy a tyre, they want to know exactly the ins and outs. What's the best? What does this? What? Even if they're never going to use it that way, they want
Yeah.
it. They want to know they can get the best possible. So it is important, but I think I understand that replacing tyres sometimes is just solving a problem you have at the time.
Mm.
The important thing for me, and advice I would give to consumers as much as I can, is don't let your tyres be a shock to you that they need replacing.
Yeah.
We know what the laws are, or we should do. 1.6 mil around, you should be checking them carefully monthly. But the cost of a very good tyre over a not a very good tyre, while it might sound expensive to spend, I don't know, £700 instead of £400 on 4 tyres,
Mm.
the reality of it is you've got to spend 400 anyway.
Yeah.
So that extra money we're suggesting you invest, take the time to work out what benefits am I going to get for it.
Mm.
Am I going to get some extra range out of it? Yes, you will. Will that save me money? Well, it might do. I mean, if you plug in at home, not that much, but it will.
Public network people, of which I'm one. Every
It
little
will make.
counts.
Well, again, it's
Yeah.
it's it's two pricing points, isn't it?
Yeah.
One's 10 times the cost of the other.
Yeah.
That's a whole different conversation. I'm sure you'll have with someone else.
Mhm.
But in that case, it has a massive difference.
Yeah.
If I'm saying, can't remember the figures on it now. Sort of 10,000 miles at home charging is about £200 a year.
Mm.
Public's about 2,000.
Yeah. Yeah, I did the maths recently, partly because I need to stop talking about this because I'm so boring. But
I'll be the judge of that.
on principle,
Yeah.
I live in a Victorian terrace house, and I don't think it's particularly fair that you have to do a planning application to put a charger on the outside of your house if you've been granted permission to have a charging cable gully on the pavement.
Yeah.
And there are different councils offer different levels of that planning application. Like either you can just do an annotated photograph, but you're still having to pay for the planning application,
Yeah.
or as we're required to do, we have to submit full architectural drawings, which is
That's
outrageous.
thousands.
Yeah, and it would,
Yeah.
I can build a construction in my garden, which is much bigger,
Yeah.
without planning permission. So it seems a bit daft, but
It is ridiculous.
yeah, and so in that process, I've sort of done some calculations on, if you did 80% of charging at home, 20% on the public network versus 100% on the public network, and it's at least £2,000
Yeah.
difference, which is, well, I mean, it makes your job marketing tyres easier, but
Well, in that case, yeah, because I mean, I'm not familiar with the figures with regards to who public charges and who home charges. Um, I'm pretty sure it's like 70-80% do home charge on
yeah,
EVs. It's something
yeah,
like that. So I'm afraid you're in the minority on
I
that.
am, yes.
So I'm afraid for people who are in your position, Imogen, really the range of a tyre is very important.
Yeah.
But I mean, it goes a little bit further than that, doesn't it? Because obviously it's more convenient to have a longer range. But I think the most important part is, when you buy a new EV or a second-hand EV,
Mm.
you'll always pay a premium for a bigger battery, won't you?
Yeah.
And it's like between 3, 5, 6,000 pounds. It could be more. I mean, and really what you're buying, on average, you're buying 70, 80 miles. Well, if you choose the wrong tyre, you're going to lose half of that overnight.
Yeah.
And we've got the facts. We've done the data on it. We've got the data. We need to do more. We need to get more facts and figures like that together. But yeah, it's such an important thing. It's as I say, I tend to forget that people are in different circumstances, and they're more receptive to different arguments.
Mm.
It's easy to do that.
Well, I think what's interesting about where we are in the, I guess, transition to electric vehicles is that, well, I guess there's two things. One, when a technology is new, it seems quite intimidating to many people,
Yeah,
understandably so.
yeah, yeah,
Um, and when it does, anecdote is really important.
yeah.
And those anecdotes are so specific and unique because where we need to go and how we get there varies so dramatically based on our lifestyles, and we're all individuals. So that need for hyper tailorization of messaging, of communication becomes very, very vital, I think, at this particular point.
I think you're right, and I think when it comes to how do we market a product,
Mm.
how do we market a product like an Ion? Because um, I, it's funny. I was working in at the Everything Electric show with you guys, and I spoke to a lot of customers, and I understood it better after that. But there's a bit of cynicism.
How
Really,
so?
do I really need an EV tire? Is there any difference?
Mm.
It's I just go for the standard ones. Now I could say, well, if they buy Hankooks, that would be great. But really, there really is a big difference. I mean, there really is a practical difference. But
Mm.
unfortunately, one of the limitations we have is because everyone's circumstances are different and drive differently, and most have different cars. I cannot turn around and say to you, this will be this will be that, because it depends. It depends.
Yeah.
And I guess some of the message might get lost in that. So it's something I'm aware of.
Mm.
It's something we're aware of. But I think the message we want to get across to people is that EVs deserve EV tires,
Yeah.
and by all means, take responsibility for yourself and try and find out as much as you can from as many sources what they are. I do wonder, because a lot of people are spending £1,000 for 4 tires on some of these EVs.
Yeah.
Now, I don't know the last white good you bought for £1,000.
I'm trying to think. I dread to think because it's one of the things you don't
No,
really want to part with that money.
no,
Yeah.
you don't really, do you? So, I mean, it falls into the same thing. But if you're forced to do that, it might just be a cooker. Well, I suppose that's top end, really, isn't it? I don't know. I've lost track of it, really. But I mean, a washing machine, £500. If you're going to spend that, what are you going to do? Well, you're going to go to the shop. You're going to compare. You're going to look at ratings. You're
Mm.
going to maybe see if you can get a free subscription to Which for a couple of days and see which is the best one in their review. And not saying I've ever done it, but I'm sure we all have. So you're going to do some research. You're going to find out. Yeah, a
Mm.
lot of people will spend double that on tyres and do no
Haven't done
research.
any research.
And it's
Yeah.
like, to me, that's, I guess I've been in the business too long. You
Well,
know,
but it's such an interesting challenge that you have of, ultimately working on a product which looks exactly the same from a distance at least
yeah,
to a cheaper alternative.
yeah,
And as you mentioned earlier, is largely a distressed purchase as well. So it's you're having to work really hard.
yeah. And again, I think what we really need to do then is, so how do we as manufacturers market the fact that we make a premium tyre that works well on, say, an EV in this instance?
Mm.
So, and we'll, obviously there's a marketing budget for things like this, but really what we're looking at here is, involvement in top tier motorsport.
Hmm.
I mean, that really
Yeah.
sets you apart. We have strong presence with original equipment manufacturers, so we work with all of them,
Yeah.
with product, and also we encourage independent validation. So we work a lot. I say we work a lot. We provide a lot of tires for evaluation, certainly with the German magazines, who were pretty much the gold standard for tyre tests, the detail they go into. I look at it and go, I just don't know what you mean. So yeah, so really that's how we do it, and really what the icing on the cake that really would set us apart is just product innovation.
Yeah.
I mean that's all we can do. We got to come up with some good ideas, and we got to tell people about it and tell them what the benefits are to them.
But I suppose that's it. I think, it's that trust. I know that you work very closely with, for example, Formula E,
Hmm.
all of the OEMs, all of the car companies that you've
Yeah.
mentioned, obviously those top tier magazines, and then, of course, just making something that's genuinely really good.
Well,
That
that
makes life a
helps.
bit easier. Yeah.
That helps. I mean, you mentioned Formula E. I mean, we're involved in Formula E. You'd have seen the Formula E car, everything electric.
Mm.
I mean, that's a really, really um, interesting specifications and technical requirements for that. So they, so you've got a car that produces maximum 400 kilowatt on boost, so about 500 horsepower, 900 kilos, um, 600 kilowatts of regen. That's what it's got to produce. So sort of throws the previous discussion on its head. But 600 kilowatts of regen is extraordinary. Um, and also, there's only one tire. There's no wet
Mhm.
weather. There's no dry weather. It's everything.
Yeah.
And the reality of it, even the sizes are quite calm. I mean, I think the front's 255 40 18. That's pretty similar to most car sizes. The technology was almost completely transferable into the Ion range. And the real
Wow.
kicker with that, we talked about how you get this power and efficiency trade off as small as possible. The real kicker with that was they are given 40 kilowatts. That's what you got to run the race.
Yeah.
Race is 45 minutes plus a lap. It's about 60 miles. You got 45 kilowatts plus you got a 5 kilowatt fast charger takes 30 seconds. So that's what you've got. So
Yeah.
you're limited with that. That's what you got for the race 45 kilowatts. Go out and fill your boots. And anything you do to increase grip and traction at the expense of rolling resistance, you're not finishing the race.
Yeah.
You know, so it's like the real cauldron of this test. I mean, it's extraordinary. We when I heard we were joining Formula E, I thought, God, we got an opportunity here, and boom, there we go.
Mm.
We got a set of EV tires. We got a range of EV tires. Never mind a set. So
Yeah.
yeah, that really transferable technology. It's been
And
great fun.
when it comes to, say, Formula One, for example, tire strategy is the buzzword of the moment, and certainly
Yeah,
when you watch the F1 movie, like tires are spoken about all the time.
yeah,
So
yeah,
it's logical that I guess tires become very exposed when it comes to motorsport because it's the difference between winning and losing.
yeah.
And it's awesome to see how Formula E is actually pioneering things that can make their way into passenger cars. In this instance, with tires.
Do you want to hear some sort of figures of the comparison? It's
Oh,
it's
go on then.
remarkable. All right. So, did you know that a liter of E10 petrol's got 9.2 kilowatts of potential energy?
I didn't know that.
Okay, there you go. You can have that. So, what does that mean? So, if you had a Formula E race and a Formula One race over the same distance, so a Formula E distance, a Formula E car would use 45 kilowatts of energy, and a
Mhm.
Formula One would use 400 kilowatts of energy.
Yeah.
That's what we're talking about here. Nearly 10 times less energy required for the race. I know it's not sexy, but it is kind of the future,
Yeah.
and it is those facts maybe, them aside. I mean, it's great racing, but that from a technical challenge from a manufacturer like ourselves with all our technicians and boffins who just want to get on
Mm.
with the next thing. I mean, it's just perfect.
Yeah. I mean, these facts are always so useful to hear because when you think about EVs versus internal combustion engine equivalents, like regardless of your politics, regardless of how you feel about the noise or whatever,
Yeah,
if you were like skipping down the road, chucking money just over your shoulder
yeah,
versus someone who's like running down the road and keeping the money in their hands,
yeah.
you'd be like, what on earth are you doing? This is like totally inefficient and so wasteful. But energy is a little bit more abstract for people.
It's a difficult thing to grasp.
Mm.
I mean,
Yeah.
I think a couple of years ago when energy prices went ballistic,
Yeah.
I think people really dialed in.
Yeah.
And then they came back down again. They're not cheap. They'll never be cheap, I don't think. That's a whole different conversation. But it really does make you, it really does make you think, well, hang on.
Mm.
These are costs. We were all paying, I don't know, £60 for electricity and gas, or £70, and then it was £200.
Yeah.
And it's like, well, hang on, I've got to save some money here.
Yeah.
Yet people are still spending 220, 230, £240 a month on doing nothing in a fuel car, in
Yeah.
an internal combustion engine, unless of course you've got a public charge, Imogen, for that. I'm sorry.
Well, fortunately,
We
my
got to sort
gym.
it.
Well, I've got to get it sorted, and I've had various conversations, and fortunately, my gym does at least have
Yeah,
free charging, which is good motivation to go there.
well done.
Um, I'm really conscious that I could chew your ear off for many more hours because,
Okay.
as we promised at the start of this is a really interesting topic that people perhaps don't give as much consideration as they definitely should.
Mhm.
So, I
Very much so.
suppose my last question is, if there is just one thing that you want people to take away from this podcast, what would it be?
I think it would be, the reason we have produced a tyre, Hankook, and produced the Ion, is to simplify people's choice, to have a one-stop
Mm,
shop, to have a range of tyres they can go to. Don't worry about the complexity. Don't worry about rolling resistance. Don't worry about this. Don't worry about that. Look into it. But we're not here to add complexity. We're here to help you. And
mm.
so, when now you've got your EV and it's coming up to maybe looking at tyres, take ownership, read into it, get as much information as you can, and let us do the complex bit, because they are complex.
They're complex, and you guys are most certainly the experts. So,
We try.
um,
We try. I guarantee, but we try.
well, honestly, Neil, thank you so much. This has been a lot of fun, and I'm really grateful for you joining us
Thank
on the
you.
podcast.
Lovely to speak to you.
Thank you so much to Neil for joining us on this particular episode. Thank you to Andy from our team who will be editing this episode. And thank you to you for listening. As ever, if you could do us the honour of liking, subscribing, sharing with a friend, doing all of the above, I cannot tell you how grateful we are. It really, really does ensure that we can carry on telling interesting and important stories from across the clean energy transition. But that's it. If you have been, thank you for listening and watching.